All right, so I had a question asked through email about completing the square to solve a quadratic equation if it has imaginary roots. Now we all know that you can use the quadratic formula, of course, but if you wanted to take something like this and solve it by completing the square, this is how it would be done. The first thing you have to do is, sorry about the paint on my hands, is isolate your C value. You've got to get it pushed off to the other side of the equation. And then here comes the completing the square part, where you take half of your B value. So my B value is 4, cut it in half, which makes 2, square it, which makes 4. So that's my magic number, is 4. So I'm going to add 4 to this side, but I'm also going to add 4 to this side to balance the equation. This is now a trinomial that factors very nicely into x plus 2, which I can rewrite as x plus 2 squared. Over on the other side, when I add -7 and 4, I get -3. Now, to solve this, I would square root both sides, and you can see the imaginary number coming into play here. When I square root this, I get just x plus 2, because square rooting something squared is going to just cancel it out. Over here, though, when I square root -3, I have to take an I out of that, but I also have to make it plus or minus because I have to account for both answers when I square root. Then if I move this 2 over to the other side, I get -2 plus or minus I radical 3. That's the exact same answer you would get if you solved it using the quadratic formula. So it can be done with completing the square, but remember, if there is a number in front of the x squared right here and it's not 1, completing the square can be very tricky. So I would encourage you to only use the quadratic formula if that happens.